All right, this is Unit 7, the review for that unit, which is 7.6. This is question number 7. So I already started this. All right, the acceleration, since this is a projectile, starts out as the negative 32. Remember, projectile, when you're doing something straight up in the air, which is what this one is, the acceleration always starts out as negative 32. You always take the integral of that, which is going to be negative 32t plus c, and then I have to give you some information to solve for the c. So in the problem, I give you at 3 seconds. The object is negative 51 feet per second. That's the velocity. Plug that in. Plug the 3 in, and you solve, and you get 45. You replace your c, and that's your velocity equation. Do the same thing. Integrate the velocity, and you get your height. You can either call this h of t or s of t. It's written both ways. I prefer h when it's the projectile because that stands for the height. Integrate, again, it's always going to be negative 16t squared when you start out. Bring it down, you again have a plus c. Go back to the original problem. It says at 7 seconds, the position is 731. You take the 731, plug it in for position, the 7 in for the time. Remember, the t stands for time. And then solve, and you get 1200. And then again, replace that c. So you have your 3 equations now. So then going to part B, when does it hit the water? That's the same as when does it hit the ground, and what is the impact velocity? When you do this, you're going to have to take the position function and set that equal to 0. So I'm going to take the h of t, which is my negative 16t squared, plus 45t, plus 1200, and set that equal to 0. And you're not actually going to do that by hand, by paper and pencil. You're going to go to your calculator and you're going to type in negative 16t squared, the actual position function in y1, 0 in y2, and you're going to find the intersection point. And when you do that, you're going to then find the intersection. Technically, there are 2. One is a negative. You don't want the negative because the time can't be negative. All right, the second one, when you do that, it comes out to be 10.18. Now, there's a bit of a warning. If you zoom 6 this, you are not going to see it. You're not going to see it come down because, again, the window goes from negative 10 to 10. Since this is intersecting at 10.18, technically that's past the window. So you have to expand your window out, probably like 15 for the x max, and you'll see it come down. All right, so once you have that, that's really part B, which is when does it hit the water. To find out the second part of that, what is the impact velocity, you take this 10.18 and you plug it into the velocity equation. So V of 10.18, plug it in, and you end up with negative 280.76, and that's feet per second. And I'm going to go back up here and write seconds there because you want to make sure you have your units on this. All right, part C, it's asking what is the maximum height. So maximum height is when you set the velocity equal to 0. So these 2 questions, B and C, are the 2 questions that I typically always ask for the projectile. One is when it hits the ground, that's part B, set the position equal to 0. The second is when is the maximum height. So it's the other end of the spectrum, it's the very, very top instead of the bottom. And that's when you set the velocity equal to 0. So the V of t is just the negative 32t plus 45. Set that equal to 0. This one you could do by hand. It's a little bit easier. And you end up with t is equal to 1.406. That's again seconds. So that is when the maximum height occurs. All right, and you use that to find out what the maximum height actually is. So you take the time, you plug it into your position now. So it's h of 1.406. And that comes out to be 1,231.641. And that is feet. So again, if you just take a look at letter B and C, they're pretty much the exact opposites of each other. All right, in letter B, you set the height equal to 0, and then you plug that into the velocity. In letter C, you set the velocity equal to 0, and then you plug that into the height. So they're just the opposites of each other. All right, part D and part E I'm going to kind of talk about together. So the displacement and the total distance. All right, so whenever you do projectile, displacement is really just going to be its starting amount minus the end amount, which is going to be 0 since it landed on the ground, minus the starting amount. So it's the end minus the start. So my displacement here is just going to be 0 minus, and then I have to figure out, well, where did I start? Well, the initial height is right here. The initial height is just your 1,200. If you took 0 and plugged it in to the height equation, you would end up with 1,200. So 0 minus 1200 is going to give me negative 1200 feet. Part E is the total distance, very similar to that. So for this one, you could technically figure out how high it went up from 1200 all the way up. So we know the max height already is 1231. So it went up 31.641 feet, and then it went down to 1,231.641. You could add those two together. The second way that I taught you to do this is just to take the integral. And when you do this, since you want total distance, it has to be the integral of the absolute value of the velocity. It's always, always, always the velocity in here. So that's going to be negative 32t plus 45. You're taking the absolute value of that. Again, absolute value is under math. Go over to number. It's the first one there. All right, you can do this under math 9. And now I need to decide what my bounds are. For these, the projectile, you're always going to start at 0. So you're at 0. And then the question, again, the biggest question I always get is, what is my ending value? Well, the ending value is when it hits the ground. So when is it going to hit the ground? Well, we already figured that out. That's just 10.18. So that's just 10.18. Go through, you actually do that integral, and the answer here should be 1,263.300. That's feet.